the geometric sequence and compound interest. So I want to tie in the geometric sequence to the compound interest because it's one of the probably interesting applications that you run into. And compound interest doesn't necessarily have to be money, but it certainly is probably most applied to money, so for business students. Now, teachers or professors who ever teach compound interest don't typically go back to the geometric sequence because of the fact that students just kind of don't remember, right? But if you are in math, it's nice to tie them in together just for yourself and to see that, hey, you know, some of these math things that we're learning are actually very applicable. Okay, so that's what I'm going to try to do. So I covered the geometric sequence, and I actually covered how the derivations for them and where they come from. So I'll put up a link up above there to the geometric sequence if you like. All right. Now, the geometric sequence is basically you have terms where from one term to another, it kind of grows or decays at a constant ratio, right? And the summation, so you can always find the nth term. So n is just how many terms you would want to be able to find. So let's say n equals, so for n equals to 1, that would be term number 1, term number 2, term number 3, and so on until you get to term n. And the equation is, it's nothing else but knowing what the first term was and then multiplying it by the ratio raised to the exponent of n minus 1. Okay, so that's that geometric sequence, and you can go back to that link if you want to remember where it was. Now, compound interest, nobody really is going to write compound interest like this because it's, you know, students are going to be like, what the heck is this? Now, I have done a full playlist for compound interest for business students, and I'll actually attach it to my website, which is the 1mjourney.com, under the high school videos that I do. But I also put up a link here, okay, on the entire playlist on compound interest, because I think for grade 10 or 11 students, it's super useful, right, to be able to know. And we all kind of are interested in money, right, in terms of growing it, investing and borrowing. So I think it's worth your time to go through that list. Now, the basic main compound interest is, the question is, after n terms of compounding your interest, you know, how much money has accumulated, how much money do you have in total? And sometimes that's called a future value. So, you know, so I'll write the equation is future value is equal to whatever you started off with, which may be known as just the principal amount. So your principal amount of money you started off, or sometimes it's called the present value. So present meaning initially. Okay, so it's one or the other. So you can have just put P or P subscript V. V just means value, right, in terms of money. And then what it is 1 plus, okay, the compounding interest, and then it is raised, and this is the interesting thing is because we have two n's here, so I have to kind of be careful. All right, so I'll put maybe a capital N in here, okay, but most of the time the formula will have a small n, but I don't want to confuse you with the small n on the left-hand side. And n is, the capital N is just the number of terms that you have, right? How many times are you compounding? So these two things are actually the same, okay? And what I want to show you here is that term number 1 is your present value. So that's your P, okay? So that's going to be your term number 1. That's your present value, which you start with. Your R, so this ratio between the terms, is going to be just 1 plus I, okay? So that's what that would be. And the capital N, okay, and then this N, so notice that, you know, so this N minus 1 is going to be really just equal to N. And you'll see why the minus 1, because we start, okay, with term number 1 being the present value, all right? So we're kind of in the sequences, you know, we label them from 1 onwards, and that's why, you know, you have this discrepancy. But let me just show you how all of this stuff is related. Okay, so if you're going to have compound interest, what it means is, okay, we'll have n number of compounding periods. So let's say that we're going to start, okay, with our present value. So you start with some initial amount of money, Okay, let me try to draw this out. So you have start with some initial amount of money. So this is maybe your present value. And let's say that this is, times 0. Okay, so that's your present time now. And then as you keep going along, so what you do is they're going to be growing this. And, so you're going to grow some interest amount. And now my interest that you have, well, what's the interest? So the interest is equal to, okay, so as you carry on, maybe let me kind of write it like, like this, my interest, I, is equal to, it's nothing else but just present value multiplied by that interest I that you had, right, initially. So after one, let's assume that it's years, right? These compounding periods that we have, let's assume that it's years. So after 1 year, you would have made whatever that interest was. Let's say if it was 8%, 10% multiplied by your initial amount. And, so that would have been, something, okay? So let's say this is your I, all right? And this is after, one compounding period or 1 year, okay? Under assumption. And what you would do is now for the following year, and now what you have to do is you're going to be taking, okay, so this amount, so really, okay, so what you have is you're going to take this amount and you're going to be adding it, okay, on top of this amount. So now let me duplicate this, bring it down here, all right? So now, after 1 year, this is what we have, okay? So let me just write this in terms. So term number 1 was equal just to present value, okay? That's after no time has passed by. Now, term number 2, which is really what happens after your first year, that's going to be your present value plus whatever interest you make, but that's just present value times your I, okay? Now, notice what I'm going to do is I'm going to remove the present value, so I'm going to factor it out, okay, from both terms, and what I'm going to have is this. All right, so that's exactly the same thing. So I'm just removing this present value, factoring it out from there. Okay, so far so good. Now, what happens in, after 2 years? So that would have been my term number 3. So term number 3, well, term number 3 is going to be, well, because now I'm going to be applying my interest on my new amount. So my new amount is this entire thing, right? So my new amount is this whole thing. So that's the value of, I guess, term number 2. So really what I have is I'm going to have term number 2, okay, plus whatever the term number 2 is multiplied by my I. That's why it's compounding, right? Because we are now adding the interest, okay, at the end of the year, and now the interest will accumulate more interest. But if I do this, okay, so again, now I can remove the T2 from here, and I'm going to get 1 plus I. And notice that, oh, well, this kind of looks very similar, right, to the one above. But here, what is T2? Well, T2 is this. This is T2, right? So if I take that, so I'm going to just copy it here. So if I take this, okay, I'm going to duplicate it. That's my T2, okay? And, okay, that's being multiplied by, so again, I'll duplicate this. Okay, it's just multiplied by this. So this is now my T3. So if I'm looking at this, then I'll say, oh, well, T3 then is just equal to PV, 1 plus I, notice to the 2, because I have 2 of these factors. Okay, so that's my T3. Now you can continue this, so to T4. Well, T4 is going to be T3 plus, okay, again, whatever the interest is growing at, okay, which is that. And again, so this is just, I'm going to remove T3 from here. It's going to be 1 plus I. And I think now you notice what the pattern is, right? Because my T3 that I have here, that's just this. That's what T3 is there. So if I bring this down again, I'm going to duplicate it, bring it down, okay? and so multiplied by 1 plus I. Now, they have the same base, right? So that's your exponent rules there. So this is just really what T4 is. So the only thing really that's changing, what is happening from term to term, I'm just multiplying each term. So notice from T1 to T2, I just multiplied it by 1 plus I. From T2 to T3, again, I multiplied it by 1 plus I. So that's what I got here. And I'm just constantly multiplying by 1 plus I, which is basically your ratio, right? That's what the geometric series is all about. So this is my R. This is my ratio for the geometric series. And now if I want to find out what Tn is, well, I know that Tn is whatever you originally started with, multiplied by your ratio R, and then n minus 1, right? So this is the nth term. But notice, the term, so this is 4, okay, but this is 3. That's why in here you have the n minus 1. And so if you continue this pattern, right, and you keep building up into these future years, all you're doing is you're just taking the previous year and adding the new interest. You're just multiplying by 1 plus I, and then multiplying by 1 plus I, multiplying by 1 plus I. And that's the geometric series. And that's why the compounding interest, okay, is nothing else but just the continuation, okay, of a geometric sequence. So you can find and you can tie these two things together. So that's why, so T1 is whatever you started off with. Your R is your ratio, which is 1 plus I. And then this, okay, this n minus 1, I called it capital N for us because that's how many terms you had in total, right? So you're always kind of lagging because this is one term over, this would have been 2 terms, right, over, but this was term 1, term 2, and term 3, all right? And then it just continues on, okay, as you pile them up on top of each other. And term Tn, that is just your future value of whatever you would make. And there is your compounding interest formula. That's exactly what it is. It's just a geometric sequence. So if you take an example, I'll give you an example. So let's say we started off with $15,000. And let's say we're compounding at 8%, okay? And let's make it per year. Make it simple. If you want, you can go back to the playlist and really study the compounding interest in much more detail. But let's say we're compounding at 8%, okay? So this would have been 0.08, okay, on an annual basis, so per 1 year, all right, okay, or per term. So in this case, if you wanted to find out, let's say maybe after 20 years, so 20 terms have passed by. Well, what would have been the answer? My answer would have been, so the future value, or really your Tn, right? Your nth term is nothing else but what did you start with? You started off with that. That's your first term. What is the ratio? The ratio is 1 plus the interest. And then terms, right? So within here, so this would have been, for us, it would have been 21 terms because we start at 0 from term 1. So this would have been 20 years. All right, so that's 20 years later. Okay, and then you can find out exactly what this is. So you can plug it in. So 15,000 multiplied by, say, 1 plus 0.08. Okay, and then raised to the 20. It's going to be a nice chunk of money. So I'll round it to the penny. Okay, and this is what you would have had. And now you kind of know how the geometric sequence is tied into the compound interest. All right, thanks for watching. I hope that you found it useful. See you in a future video.